Hi everyone, I'm just going to do a really quick one with you today. This is question 6C from the 2022 higher level paper. We've been slowly working our way through that paper. This one is, before I get into the question, just my usual reminder that if you want to make the most out of the video, don't just watch me do the answer. Go ahead, try it yourself, have your answer, kind of basically use the video to correct your work. Unless of course you're just really stuck and you need to get me starting you off, okay? And in that case, I would take the video step by step and only watch what I need to get moving with the question myself. Now this one's kind of a simple one, so it might be more of a you either got it or you don't kind of one. Just another separate reminder, we're slowly working through this paper, like I said, but if there's another question that you've been working on that you'd like me to look at for you, let me know. I can do a video of it. It doesn't have to be on the 2022 paper. It could be anything. It doesn't even have to be an exam paper. If you have a question out of your textbook, I'm familiar with most of the textbooks. Just write in a little comment on the website or social media and I will get to it as soon as I can. Just trying to make it as helpful as I can. So with that, let's get started. I don't think this should be too much of a long one. It's one of those ones where you're drawing force diagrams and people either get them or they don't. In terms of the exams, when you're correcting the exams, you'll find lots of weird answers. So I think maybe people overcomplicate them, okay? And because you're in an exam and you're asked to draw some forces, you kind of start sticking them in everywhere because you aren't sure and you're trying to cover yourself. It's not always the best approach, okay? So keep it simple. If you find them hard, I definitely say go back to that section in your book or your notes and just practice them by doing that same thing. Like look at the question. I know that for example, the real world physics book have loads of like those solved questions, the kind of problem sets. Look at the question, cover the answer, try it out, test yourself until you think you can get more comfortable with these. All right, so question 6C says, draw a labeled diagram to show the forces acting on a piece of wood floating at rest. Let's just do the drawing of the piece of wood floating at rest. I'm going to assume it's floating at the surface. I think that's safe enough assumption. So here I am with my pen. Give yourself lots of space. There's no reason to be doing cramped diagrams. It makes it harder for you and it makes it harder for whoever's correcting as well. This is my kind of tank of water. Let's pretend I have a tank of water in my lab. And there's my piece of wood. I'm just going to, that's a wooden block, color him in really nicely, beautiful. And I'm just going to say that he's floating right there on the surface of the water. All right. If you really want to make sure you're covered with the labels, you can keep going. But really, what the labels they want to see are the labels on your force vectors, okay, or your forces. So here he is in the water. And just for completeness, tank, but I will say if you look at the marking scheme, you're not getting any extra marks for labeling your diagram like this. I'm just showing you so you understand the picture, okay? And it's floating, so there's something pushing it up. But because it's on Earth, we're assuming it's on Earth, they haven't said it's anywhere else, we've got gravity pulling it down, okay? That's basically all that there is to this, okay? You can get really wrapped up, keep it simple. I don't normally change colors because I know that doesn't really work for everybody, but just for the sake of the diagram today, I'm going to, could you see purple, blue? I'm going to go for blue, okay? If anyone has a problem with that, let me know and I can just make sure to either stick to black and white or stick to all the same color. I'll have a solution attached to this at the end anyway, which is all one color, so it should make sense. Okay, so this one, do you know what I'm going to do too? This is the thing, you don't have this option in your exam paper, but I'm just going to make a bigger size just to really highlight this isn't my diagram. Okay, I've got a force downwards, and we know what's pulling or pushing the wood down is its weight. Okay, so the force of gravity is its weight. On the marking scheme, if you're interested, if you're at that point of practicing that you like knowing how your marks are going to be, it said that you get 3 marks for weight labeled downwards and You could do it a different way actually as well, but I probably would also accept, now it doesn't say this in the marking scheme, so just a warning, I would probably also accept gravity or weight. Then the thing is pushing it up, because if it was just gravity working on the block of wood, it would be sitting on the ground, okay? It would just sink, it wouldn't be floating up like that. So what's keeping it up? And the word we use for that when it's in the water is buoyancy, okay? And my spelling and my writing could use some improvement. Hopefully you can read this, buoyancy. Buoyancy is just the upward force, and sometimes also called upthrust. So if you find one of them, you remember one of them better, great. So it's either buoyancy or upthrust, pushing the wood up because the water is keeping it from hitting the ground, and the gravity and the weight is pulling it down. Now you might say my scribbly diagram isn't all that clear, so just to really hammer it home, and again I'm looking at the marking scheme here with this, and that would be attached to, so you'll have something to compare it to. If you really want to hammer it home, you could add in a statement as well saying that they are equal and opposite force vectors. You should, if your diagram is good and clear, that should be obvious. So if I had something and it was like, this is what not to do, okay? So I've got my block and I've got this like massive big one here, and I'm saying that that's huge gravity keeping it down. And I've drawn like just a little baby one here saying, oh yeah, that's upthrust. It would be a bit confusing to someone correcting it because you haven't necessarily got them equal. Well, you've got them, they're not equal, they're opposite, but they're not equal in size, okay? And anything else to the side or anything, just no, okay? So I'm going to get rid of that. I've tried my best with my diagram, and I'd say most people can do this. They're roughly the same size, okay, given that I'm working on like pen and paper, and they're in the exact opposite direction. But if you really want to clarify it and hammer it home and get those extra few points, you could say or mark somehow that these are equal and opposite force vectors. So I would write a statement. Now again, remember all these questions are 7-mark questions. The block is floating at rest. Now I'm just actually copying what the question said that first, so you're not really getting anything for that. I'm just kind of talking to my examiners, and the block is floating at rest. So that must mean, or you could do your little, if you use a verb, therefore, dots are hard to do with my pencil. So therefore, the forces are equal and opposite, okay? They are, what we want to keep clarifying, equal in magnitude. That means they're the same size, basically, okay? Because it's at rest. If it wasn't, if it was moving, that would mean that one force is bigger than the other. So it's equal in magnitude and in opposite directions. Okay, and that's really securing every possible mark you could get there for that question, at least last year, 2022. Okay, now, like I said, I have the marking scheme attached, and just, I don't know if you're interested in this, I'll do it for today, and I'll see if I keep it up, depending on the question, I suppose. I'm going to come along with my red pen, as if I was marking it for you, and I would say, okay, you've got weight labeled downwards, that is 3. Am I right? That's 3. You've got buoyancy and upthrust labeled upwards. That's 2. Now the way that works is if you didn't have gravity, but you did have buoyancy, you'd get 3. So you get 3 for the first one and 2 for the second one. Doesn't matter what order you're in. And then for either for having nice clear vectors, or having some, whoa, what kind of tick was that? Or having a statement that just really clarifies it, you get that extra 2. Okay, and I do total 7. Okay, so if you're, I can keep that up if people are interested in having their marks and seeing how where each bit got. But one reason, excuse me, a bit of cold. One reason I'm reluctant to do that too much is that, as I said before, the marking schemes can change from year to year, and I don't want, you shouldn't get in the habit of, if I always do it this way, I'll always get full marks, because it's completely changeable. Another year, you might have just gotten full marks from a diagram, you might need to say anything, you mightn't, it might have been a completely different question, it likely would have been, okay? Again, if you have questions about marking schemes, let me know. I'll do my best to answer you. And if there's any question that I don't know the answer to, I can check with someone who does, because as you can imagine, most physics teachers know other physics teachers. So we always have someone to double check with. Yeah, so I hope you found it helpful. It's kind of a quick one, but it does catch people out if you start getting bogged down and confused in it. So hopefully that's nice and clear, and definitely practice some more if it's not. And if you just don't even know where to start with it, do let me know and I'll do whatever I can do to help you out. Okay, thanks for watching. Talk to you soon. Bye.